Hey there, Geometry. We are in Unit 3, Lesson 11. We are splitting triangle sides with dilation, Part 2. Okay, we started this last lesson. So, here we are. What do you notice? What do you wonder? Okay, get my pen going here. We've enjoyed doing these in class, but here, what do we notice? What do we wonder? I have a given of two parallel lines, and I see those parallel lines right there. Is there anything you notice or wonder about those? I notice I have a trapezoid right here. Okay. I have a trapezoid, which is pretty cool. I see a big triangle and a small triangle. Looks like it might be dilated triangles. So I'm going to write down a small triangle inside a larger triangle. I see that. Yeah. Parallel lines, I got a trapezoid, I have a small triangle inside a big triangle. That's really all I can see. Next. Okay, so prove it with parallel segments. Does a parallel line to one side of a triangle always create similar triangles? Again, if we were in class talking about this, would be great. Parallel, create several examples. Decide if the conjecture is true or false. Does a parallel line to one side of a triangle always create similar triangles? So I have a parallel line. That's a terrible triangle. Oh, and we moved. So if I make a line parallel to this one, doesn't make similar triangles. Well, we've talked about one of the rules for similar triangles, and it's two congruent angles. Well, I've just made congruent angles because these right here are corresponding. Because when two parallel lines are cut by a transversal, you have corresponding angles that are congruent. We know that. I could name them angle 1, angle 2, angle 3, and angle 4. I have angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4 because when two parallel lines are cut by a transversal, corresponding angles are congruent. Okay, it's a theorem we learned in a previous unit. Okay, so that is definitely a truth that would help us prove similar triangles, because we also have triangle similarity statements that we learned in the last lesson, and it's angle, angle. So if I have two angles, two angles in one triangle are congruent to two angles in another triangle. the triangles are similar. Okay? Cool. Let's see what else. Just looking at something that maybe help you guys. If that line was extended, okay, that might help you see the two parallel lines in the transversal. Or here we have two parallel lines in the transversal. Okay, I didn't think that might help you guys see it a little bit better. Okay. Here is their drawing, which is similar to the drawing that I just did. Sorry. Find any additional information you can be sure is true. Well, I am sure that this angle is congruent to this angle, and this angle is congruent to this angle. Okay, I'm sure about that. See previous parallel line statements. On the last page, okay? We are sure that is true. When we have two parallel lines that are cut by a transversal, the corresponding angles are congruent. Okay, we've proven that. We've taken tracing paper and drawn it over it, and we've measured them, we've proven it. So, to write an argument that convince a skeptic that our conjecture is true, we also did that. Okay, pretty simple today. Okay, we've also already done that. Okay. And look, our stuff's moving along with us. I hate it when that happens. Let's see if I can change it. Yeah, it stopped. Okay, let's look at this. Okay, this is important on how to calculate things. So if you think that you're done and you want to check out, please don't. All right, so find the length of each unlabeled side. So we know that AB and EF are parallel. I'm just marking them that way with those arrows. We also know that they're perpendicular, so that is 90 degrees. So find the length of each unlabeled side. So I want to find this length, that length, that length, and this one's going to be easy. I don't really need to find AE, but I can. Let's see, 7.5 minus 3. So this side is 4.5. And actually what is going to help us is not really X, but DF. Because what we have here are dilated triangles. So I have A, B, D, and I have that's terrible triangle. D, F, E. So I know this is 4 and 3 and Y. And this is X and 7.5 and Z. All right, things we know. This angle is congruent to that angle. This angle is congruent to this angle because I have two parallel lines cut by a transversal. Therefore, the corresponding angles are congruent. And when I have two angles, I can say that the two triangles are similar. Similarity. So triangle ADB is similar to triangle EDF. Now let's go. We're going to do this thing. So the sides that are proportional are 3 to 7.5. Okay, 3 to 7.5 is equal to 4 over x. So once I've drawn that ratio, sorry, I need my calculator. I have the same one as some of you guys. So I'm going to multiply down. I have 3, oops, oh gosh, I hit the button on the pen. Let's erase that. Hate when that happens. 3x is equal to 4 times 7.5, 30. Divide both sides by 3. X equals 10. So I know this is 10. Okay? Now we want to get y and z. Well, I don't have anything to compare. Like, what I do is I set up ratios as this side is similar to that side, this side is similar to this side. But I don't have y or z, so I can't do that. But I can use the Pythagorean theorem because, oh gosh, hold on. Because they're right triangles. So let's do that with triangle 1. I can say a squared plus b squared equals y squared. So 9 plus 16, 25, square root of both sides, y equals 5. I can do the same thing with triangle 2. So 10 squared plus 7.5 squared equals z squared. 100 plus 56.25 Oh my goodness, this is driving me crazy today. It's not resetting. All right, it's coming with me. I just need some more space. So I get 100. Oh, I can hold, oh, there we go. I can hold it together for decently long, then I get frustrated. I have 156.25 equals z squared. Take the square root of both sides. And z equals 12.5. And I can check that. I can say 3 over 7.5, 3 divided by 7.5 is 0.4. Let's change colors. 3 divided by 7.5 is 0.4. And then I can do what we had, 5 divided by 12.5 is also 0.4. 12 divided by, nope. Oh my gosh. 5 divided by 12.5 is also 0.4. So we got our ratio correct. All right, that's all I have for today.